Assalamualaikum warahmatullahi wabarakatuh. And how are you? Today is our week 13, right? This is about simulations. We still have 1 week more, right? And I hope in this chapter you can understand what is the function of simulations, and also how we can do simulations using software. Actually, I just give you the introduction, yeah, because the simulations is very important in industrial engineering, and also it will make the 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 problem become more easier to be calculated or identified. All right, let me see what is the simulation. Okay, simulation is a descriptive techniques that enables a decision maker to evaluate the behavior of a model under various conditions. Okay, simulation is a descriptive technique. So it will very helpful for decision maker when they want to evaluate the system that happen in the manufacturing. Yeah, for example, like bottleneck, waiting time, and also we can see how many output from the system based on the data, so we can evaluate, and also we can see what is the queue number, and the bottleneck and so forth. We can see it in the simulation. All right, simulations model can be complex situation. We can make a model complex situation become more easier, yeah, using simulation. And then model are simple to use and understand. Of course, if we calculate many things in the industry, yeah, starting, for example, starting from raw material and then process and then output, yeah, we, in the process also has many stage. So it will very complicated if we evaluate everything one by one. By simulation, we can calculate it very easy, but the important is how we can input in the data, input the data in the system of simulation. Model can play what if experiment. So when the condition is not possible to be decided, so we can change the situation. For example, today we want produce. If we produce uh, 100 product, so what is the time required for this? And then we can also try to change if we produce 200 or 220 and something. So we can see how many input, how many output we can get. Yeah. So we can evaluate the system very simple and easy, and we can make a decision. Yeah, when we get the result from the experiment. Of course, when the real condition will be different, but it's maybe not too much different. But we can try to evaluate the system accordingly. Yeah. And then extensive software package available. Now, in UTM, we use Arena to simulate, and also we can use Excel, yeah, for manual calculation. And also we actually so many software that can be used to do simulation. The simulation process, first we identify the problem, of course, what kind of the problem we want to simulate, and then try to develop the simulation model. Later I will show you in Arena, yeah, based on the, what is it, based on the question. I will try to show you how to simulate using Arena, yeah. And then we can test the model and then develop the experiment. We change the data, yeah, and then we can see the output, and then we can see the processing time, we can see the bottleneck, yeah, or waiting time and so forth, yeah. And then run the simulation and evaluate the result. All right, and then the third is repeat number 4 and number 5 until results are satisfactory. So in simulation, we can change the situation, we can change the condition, like in the previous like in the previous slide. What if? What if mean we can change the situations based on our condition in the real manufacturing process. Okay, Monte Carlo simulation. Monte Carlo method, probabilistic. This is about a probabilistic simulation technique used when process has a random component. This is identify a probability distribution and also set up interval random numbers to match the probability distribution. Because in the simulations, normally we can see exponentials, normal distribution. We can see later. So we need to identify the probability of distribution, and then obtain the random number. Random number, okay, in Excel we can generate the random number. We can also generate automatically in the software in the Arena. Yeah? Interpret the result. Okay, this is the example, yeah, example of the simulation. So we have a probability like this, and we can see the cumulative probability between this one and this one. Yeah, you add this one and this one become this one. You add this one and this one become this one, and then number of breakdown. Yeah, number of breakdown one, and then also this is day, this is random, and then this is the calculations that we use in the simulations. This is only example. Yeah? This is also simulations using Excel. Same thing, yeah. And then we can simulate this is the random number, and then we can simulate the demand. Okay, this is the example. This is the simulating distributions. There are several types of distribution. First is Gaussian. This is about mean of distributions required, and then normal distribution. Need to know the mean and standard deviation. Yeah, you know the standard deviation, right? The between the real data. For example, we have the data is 5, so it can be 0.3, 0.5 between 5. So I mean between the real data. Okay, simulates values mean plus random number multiplied by standard deviation. So this is a uniform distribution. You can see this one is 0. Yeah, simulate value is A plus B minus A. A plus B minus A. Yeah. So we multiply by random number as a percentage. This is a negative exponential distribution. Yeah, you can see this one is the frequency, and this one is the time or total time. Yeah, this one is time, and then we can see this become lower and lower using this formula. Some of the simulations, computer simulations here is you can see simulation language. It's really a lot of simulation in industrial engineering you can try to simulate the problem. Okay, advantage of simulations. First is solve the problem that are difficult or impossible to solve mathematically. Of course, it will help. Yeah, so when you run the system, you can see directly the result. Allow the experiment with the risk to actual system. When we do the experiments or simulation, so if the situation is not possible, so we can change the situation. If you do it in actual system, when you simulate it, so it will affect to the overall system. So before we do the real or actual systems to be implemented, so we need to make a simulation first. This is very important. And then comprehensive times to show long-term effect. So when we do simulation, for short time, it will affect for long-term use. But when the situation changes, we can change also the simulations again. Yeah. And then serve as training tool for decision maker. When the decision maker want to decide the decision, yeah, so they need to evaluate the system using simulation first. So when for example, the situations they have based on the data they input, for example, the delay time and also for the bottleneck, we can identify in which part or how many bottleneck in the system happen. Yeah, so we can get a better decision when we do simulation rather than we don't do any simulation. Okay, this is the limitation of simulation. This is not a produce optimum solution, of course. Yeah, this is only simulation. Sometimes we have an error. This is different with real data, but still better than we don't do simulation. Model development may be difficult. Yeah, and also computer run time may be substantial. And also Monte Carlo simulation only applicable to random system. Okay. And then why you need to simulate? This is math. If the mathematical model is too complicated, and also we can easier to simulate than reality, and also software and hardware permit modeling. Of course, yeah. When I already explained to you, when we do simulation, it can be very important before we do a real implementations of our planning. So we need to make the simulation first, and software and hardware permits modeling. And then this is step of simulation. First, problem simulation. You need to make a problem simulation, model building, and data exploration. Model translations, verification and validation, experiment planning, executions, analysis, and implementation and documentation. Okay, I show you a little bit about the simulations using Excel, yeah, and after that I will show you how to use the simulation using Arena software. Wait a minute. Okay, for example, this one, then I just read this one to you, and then let's see. Okay. Okay, for example, this, yeah. Okay, this is a simulation using spreadsheet. We use a random number, yeah. This simulation is designed to demonstrate skill system with a single server. Okay, student will need to model the system and relate their knowledge in simulating random service time and random arrival time using spreadsheet. Okay, random service time and random arrival time. For example, this one, the about the queue system when you go to the bank, for example, yeah, or you queue for pay the food that you want to eat in the what is that, in the shop, yeah. And then this is this example. The simulation is designed to demonstrate a queue system with a single server. And then single server means one operator only. Student will need to model the system related knowledge in simulating random system service time and random arrival time using spreadsheet. To complete running simulation will generate historical data from which the student will examine performance of the system. Simulation is computerized using Microsoft Excel. Okay, I will not read this one. I will show you directly to the data. Okay, for example here, yeah, for example here, the distribution of time between arrival, yeah, the maximum arrival is in 1 minute. Minimum time arrival is 1 minute, and then maximum is the 8 minute. Okay, this one is the distribution of service time. This is the service process time, yeah, in minute, 1, 2, 3, or 6 minutes. The probability is 0.10 min. For 1 minute, the customer come, is the probability is 0.1, and for 5 minutes is 0.1 also. And for example, here is for 4 minutes the probability come, and to service is 0.25. Okay, and then the objective is to analyze the system by simulating the arrival and service process time for 100 parts, and to examine a variety of typical measure of performance in Q model. Okay, I will show you. First is develop logic model for arrival events and service process event. And then this is the how to do the experiment or simulation. Okay, this is the table. Yeah. Okay, we'll show you this one directly. Yeah. The result is present the data result simulation table gained from both simulations to know. You can see when we do simulation, we can see here we can try to calculate total time run for processing 100 part. You can imagine if one by one is very difficult, yeah. But this one is for 100 part. Yeah, the average time between part arrival for 100 part and so forth. Yeah, this is for entity to measure entity for the part. This is for machine. Okay, conclusion. Okay, see this one. Okay, let me see. This is the simulation will be like this. I'll show you. Okay, this is the simulation. This is the data. Yeah, this is the data that we want to calculate. Yeah. Okay, and this is the probability. Okay, this is inter-arrival distribution part probability. This is for part. Yeah. Okay, for this one is for service. For part, we assume this one is 0.125. For the service time, yeah, for the service time, this one 0.125 is obtained from. Wait, I show you. This is obtained from 0.125. Wait a minute. Okay. We just show you in the lab the spreadsheet. Yeah. Cannot find here. Okay, this one. You can see in the spreadsheet here. Okay, assume this one is 0.125, the probability. This is the cumulative. Yeah, just add, and then you get 1. And then this is the data from here. Yeah, the data from here. Okay, this is the data. Yeah, and then you put it here. Put this one in this part. Okay, and then we try to find the cumulative. After that, we try to calculate for the distribution of part. Okay, this one is part. Yeah, part. We need to calculate for 100 part. 100 part. So we just put it this one until 100. Yeah, part 1 until part 100. This one. Yeah. All right, and then we calculate we put the arrival random. We put the random. This one is this is the random value. You can just type RAND. We need to put it. This one is Monte Carlo random, and then the inter-arrival time is obtained from this. The calculation is quite along here, yeah. But I just want to show you. For example, this we use the probability, okay, inter arrival time here, and then we use the cumulative probability using. I will not show you how to calculate this one. Actually, you can see later. I will distribute maybe this file, and then based on the calculation, we use if the data is sick, and also the arrival time is based on this one same. We just, because this one is the first time, this one will be the first, and then we can arrange for the arrival time. This one is the cumulative of this, you add this one, cumulative, okay. And also for the activity, for the process time, this is arrival time, this is a process time. We use random, and also this is a service process time, we use if again, okay, we use if again using this, okay, if, okay, this one, okay, I will not show you, just I want to show you the simulation, okay. The result will be like this. So I want to show you, we can calculate actually by this simulation. We understand the idle time, okay. As the output, we can also can identify the time part spent in the system, and also we can see time service process end. This one is actually to make us easier to identify until the 100th time. Okay, like this, when we run, just press F9, for example, I press F9, this one will be automatically generate, automatically generate based on the random data. I mean random data here, okay. And then based on this one also, we can see this one will be automatically changed. If we press F9, this one also automatically changed. So based on the data, we can very simple and easy. We can try to make, for example, 10-time simulation. Okay, one. This one we will get, we will get this data. Okay, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we try to generate the average of a 10 simulation, for example, and then we can see the result, maybe the closer result that may be close to the actual system decision, So that is the importance of simulations. This is for a single server. Okay, just want to show you, and then I will try to show you how to simulate using Arena. This is a single server, but for Arena we can simulate using 2 or multiple server. For example, here, for example, wait a minute. Okay, this one, Okay, for example, this one. You simulate this system. For example, you are a manager that responsible for paint shop of toy manufacturing company and want to build of your current painting process. Your objective is to increase the output and to meet the additional demand. You would like to use the model to look for the bottleneck. You see, we want to identify the bottleneck. We can see, and also we can see the, sorry, I want to, the sharing is correct. Okay, correct. And test the change to the system. Okay, the paint shop processes 2 different toy part types. Okay, 2 different type of toys. First, we can see the part type enter a paint shop from an inventory store where they undergo several different processes before exiting the system. The time between arrival for the first part type is toy boat is exponential. See, this one is exponential, yeah. The distribution, yeah. And then we mean 5 minutes, exponential and 5 minutes. And then the time between arrival for the second part type toy truck exponential with a 8 minute. Okay, and then both part types and then enter the paints preparation process when they are mass size 1 or 2 operator in order to complete process preparation process once the preparation operator has been sized. Okay, just want to show you like this, yeah. Based on this, what is the one, yeah? What is the question? Okay, we need first to make the logic for the arena development model. Yeah, like this. We try to develop this and then we set up everything here based on the data we obtain. Yeah, the data, for example, here, yeah, 5 minutes. Yeah, the arrival is 5 minutes, and then this one is using infinite. Yeah, this is the random is exponential and so forth. Yeah, I will show you. Okay, the result will be like this. I have tried this to simulate the system. When you simulate this, it will be like this. Yeah, this is the toys. Yeah. Okay, this is the toys, and this is toy truck. This is toy boat. This is the process. Yeah, several process in this toys make. Yeah, and also you can see this, the delay pane can put the delay. Also you can see the release pane, inspection tool, and this one, if the toys is not pass the inspection, it will go to this post toys failing inspection, and if complete will be here. Okay, starting from here, we need to put everything here. Just double click here. For example, like this, you do create here. For this one is create, yeah. You put it like this, drag it, yeah, and you go to assign part. Put the assign part here. Assign. You go to assign, maybe here. Yeah? Assign will be here. Okay, wait a minute. This one is assign attribute. Yeah, you can put here. Wait a minute. Okay, this one is assign. Yeah, click this assign. Okay, and also you can put this size. You can use size operator. This one size. Okay, in this also you can put, for example, this one create, yeah, and then you try to click size is here, yeah, size. Can go to here, go to advanced process, to go to size here, size. Yeah, just click and then drag it here. We try to make the same thing, yeah. We try to make the same model like this. Okay, and then you can go click process again. Delay, sorry, this one should be delay, click delay. Okay, and you can click here. What is this? The release here. Okay, and this one is for delay, for fine delay again, click delay. Okay, delay and release pane mode. Yeah, release. This one is release 2. You click release again. Okay, and then release, and then inspect tools, inspect toys, inspect. This one is type of process one. Process one. This one is size here. This one is inspect type. Inspect. Inspect. Wait a minute. Okay, this one is the process, yeah. Process, inspect process. You can use type of process, this one. And this one is decide. Decide, click decide here. Okay, and we go to this one is dispose. Dispose one and dispose two, for example. Yeah? Okay, and then you connect it. We make the same thing with this, yeah. This one is create. This one is assign. Okay, you just delete this one. Okay, and then you connect it. Connect it using this connect. Yeah, connect. Click this one to this one, and you can right click here, repeat last action. Click again here, again repeat last action again like this, yeah. Okay, like this to connect it. Sorry. Repeat last this one connection again. Again. Okay, show you. And then this one, if fast, we can use this. Okay, and then you can go. Sorry, this one not finished yet. Just click this one and go to here. This one and this one to this one. Okay, the same like this, yeah. If you do like this, you drag it. It will be like this. And then you can try to put the instruction. Yeah, same like what the instruction here. Okay, just click everything, just follow this, and then try to simulate the result. We show you the result. Okay, based on this, you can try to simulate this one. All the thing you put it based on the instruction, and then you run it by clicking this. Yeah, you run it, click this. But I want to delete this one because this one is the copy of this. Yeah, the same thing. Okay, for giving the name, just double click here. Okay, click the name. Same like this, yeah. Put the name. Yeah, and then this one also put the name. All right, and I need to delete this one and this one. Okay, when you finish, we can try to simulate. Right, this one. Simulate using this part. Okay, we simulate this. If not correct, so it will trouble and cannot be run. If you can run it, so it will be like this. Okay, this one is 6 hour, 6 hour, yeah. 6 hour, sorry, 6 hour, 9 hour walking. Okay, 9 hour. Oh, I think this one is, you can see, yeah. And you can make it faster if you want. If you don't want to wait, if you don't want to wait, it will be like this. If you want to see, oh, it's very interesting, right? And make it faster. Okay. Actually, this one this one is only the animation, yeah. You can make it faster, and then after, based on our setup time, our constraint, and our data, it will show the result. Okay, this one is 8 hour. Okay, this one is 8 hour, and then we can see the output. Okay, we can see based on our data, we can get the number output is 125, yeah, based on our setting data. And also we can see this one, for example, Q. This one is Q, waiting time for inspection. To inspect the toys, the waiting time is this one, the total waiting time. And for the size, this is the result. This is waiting time. And others is the inspect toys. Q for the number of waiting is this one. Okay. And also we can see okay, so many things actually we can read here. Okay, this is the entity time. Okay, for the entity board time, the maximum process is the 14 minute. Yeah, 14 minute. The minimum time is 7 minutes. This is all the same thing you can read. Yeah. Okay, this one, and this one is the entity for detail summary. You can hear the total time for board. Total time is 20 minutes. For the transport time is 0, and then the value for this one is one average. Yeah, this one is 10 minutes. And then this is the number in, total number in for toys, total number out for toys. Okay, and then the total is for both is this one, number in is for, you can see his number in is 140. This one is the number out is 125. Okay, and then we can see this one based on in output, so how many percent, some of them is defect, right? Any problem and or waiting, the output is less than the number in. Actually, you can use this software for your PSM. Yeah? It's very interesting if you can analyze the system in the industry. You can search what kind of data you need, and then you try to input it. It become your PSM. All right. Maybe I just want to show you a little bit this later in maybe next year. Yeah, you will get this in the manufacturing system. Yeah? This is the number of busy, number of schedule, number of size, and so forth. Okay. Okay, maybe okay, you can see here also the busy pen board for the pen board busy condition is the total number of observation is 34, and then the average time is number busy is this one. Okay, so the busy one, the total busy is 65%, 65.65%. Fail and idle you can see here also. So very simple. If you can use this as your data analysis, yeah, it's very helpful. Maybe just want to show you how to use the arena. Yeah, this is only the introduction, and thank you very much for today's class, and Assalamualaikum warahmatullahi wabarakatuh.